In the last example, we worked with rational expressions where the denominators were simple or single factors, in which case you just multiply the denominators together to find a common denominator. Often, however, that's not the most efficient way to deal with adding or subtracting rational expressions, and you want to find a least common denominator, and so that's what we're going to do here. Let's start with fractions, regular fractions to start with, and I want to show you the method that you're going to use with rational expressions, or I recommend you use. I think, if you look at this, think about it a little bit, you'd probably see, if I take multiples of 12, multiples of 18, it's like 36 would be my common denominator, then you go use, and that would be your least common denominator. But sometimes it's not that obvious, and certainly with rational expressions, it won't work to simply do that. So I want to look at a method where you can find a common denominator, and what I recommend you do with numbers, and with rational expressions we'll do the same thing, is take the number and find the prime factorization. 12 is 2 times 6, and then 6 has factors of 2 and 3. So the prime factors of 12 would be 2, 2, and 3. Do the same thing with 18, and you can make a factor tree. I'm doing this one kind of in my head, or more in my head. 18 has a factor of 2. It would be 2 times 9, and then 9 has factors of 3 and 3. So this would be the prime factorization of 18. Now the method is to find a common denominator is you'll look at the different factors here, and then for your common denominator, take them the most that they appear. Up here with 12, we see that there are 2 2's. So I'm going to need 2 2's in my common denominator. So I'm going to need 2 times 2. There's 1 3 here, so I'm going to need at least 1 3. If you come down here, there are 2 of them, so I'm going to need at least 2 in my common denominator. So I'll take those 2. Okay? And that now we should be all set. These are the only 2 factors we had to consider here, 2's and 3's, but we have to get them again, the most they appear in any single factorization. So multiply these out. 2 times 2 is 4. Times 3 is 12, times 3 is 36. So we've shown that the common factor, or least common denominator, I should say, least common denominator is 36. So let's rewrite these. Just to do this quickly, I'll rewrite this fraction in 36. In order to make 12 36, I had to multiply it by 3, so let's multiply the 5 by 3. In order to make 18 36, you have to multiply it by 2, so I'm going to multiply the 7 by 2. And so I have 15 minus 14 over 36. So combining these 2 fractions or subtracting them, you'll end up with 1/36. Let's try this with rational expressions. Here are the 2 fractions that I would like to, or rational expressions, I should say that I'd like to subtract. So let's do the same thing we did up here. I'm going to take these 2 denominators and find the prime factorization. So I'll put it up here. Let's take x squared minus 10x plus 25. That should factor as 2 binomials if we're lucky. And it looks like it will factor as x minus 5 and x minus 5. So it has 2 factors of x minus 5. Let's take 2x minus 10 and factor that. There's a 2 in common, so I'm going to factor 2 out, and what we're left is x minus 5. Finding the common denominator now, or least common denominator, we need to look at the factors like we did up here. First of all, let's look up here. We have 2x minus 5. So in your common denominator, you're going to need 2 factors of x minus 5. And then let's come down to this one and see if we need to add anything. This has 1x minus 5, so we're all set because we already have 2 of those, but we're going to need a 2 because there's no 2 up there. So I'll put that in front. I would use this as my least common denominator. Of course, now we need to re-express these fractions like that. I'm going to put them in factored form. X minus 5, x minus 5. I'm going to leave a little space in this case. And let's write this as 2 times x minus 5. Okay, and I'll do the work right here without copying it again. Our common denominator is going to be 2 times x minus 5 times x minus 5. I have both those x minus 5s there, but I'm going to need to multiply the denominator by 2 in order to get the denominator that I need. So I also need to multiply the numerator by 2. So that is expressing this fraction with this denominator that I need to put these two together. Let's look at this one. I have 2 and I have x minus 5 here. I also have x minus 4. I'll put that up there. In order to get the denominator I need, I'm going to have to multiply the denominator by x minus 5. And if you do that, I'm going to have to also multiply the numerator by x minus 5 so you don't change the value of the expression. Okay. So now I have the same denominators. Let's try putting them together. Here I'll have 2 times x minus 5 times x minus 5 again on the bottom. Putting the two together, I'm going to have 2x minus x minus 4 times x minus 5. Okay, let's put these two together. I want to multiply that out. And again, the denominator will be the same. You could also write this as x minus 5 squared if you wanted a shorthand. I'll have 2x. Let's multiply this out with FOIL. I'm going to have minus. And you could take this off to the side and do it, but I'm going to do it in my head. I'm going to get x squared. You're going to have a minus 4x minus 5x. We'll have minus 9x. And then we'll have plus 20. And notice that I left the parentheses around that. You have to be careful here that you subtract this entire thing and not just the first term. So let's remove the parentheses now, and I'll have 2x minus x squared. Remember, the minus will distribute over this. Instead of minus 9x, it will now be plus 9x, and then minus 20. Copy the denominator back in. Let's simplify this. I have the opposite of x squared plus 11x minus 20. This problem is a little tricky. I want to see if I might be able to simplify this. I'm going to, now normally we don't have a minus in front of the x, so I'm going to factor a -1 out of that just to change it so it has x squared positive. So x squared minus 11x plus 20 . Okay, and let's see if we can factor this x squared minus 11x plus 20. Let's see. There are two factors we can multiply to get 20 and add to get -11. How about, it doesn't look like it. 1 and 20 won't work. -1, -20 won't work. -2 and -10 won't work. -4 and -5 won't work. So it looks like we're done. We could write this as our answer. There's no point really in leaving it like this. I would probably leave it like that as my answer. Of course, you should always go back and note your restrictions. The only one we have to worry about, x cannot be equal to 5. Otherwise, it would make we'd be dividing by 0.